Hi everyone, are you able to hear me and see my screen clearly? Yes? Oh, you can see. Click on the chat and you will be able to see what is it. Hi Abhinav, hi Anup, hi Kush, hello Nitin, hi Prashant, hi Sapna, hello Saptriti, hi Sheikh, hi Ted, hi Thomas. Great to see you all today in the session. I have started the recording and I hope it's working fine. Let me just take a look. Yes, it's working. All right. So today we are going to discuss the Spark SQL, data frames, and Spark R. This is a very, very important session. And so far we have been able to handle unstructured data. Using RDD, we were able to handle all kinds of plain text data and other even the semi-structured data we were able to do. Okay. Is my voice coming through clear? All right, great. Great. So far we have discussed this part of the screen where you see the unstructured, as in although RDD had many elements, but each individual element or record we did not know anything about in form of data types of the columns or the fields in the column, fields in the records. I will again come back to it, right? So an RDD is a collection of element where each element could be anything, right? Not necessarily a column, or it could be string, it could be binary data, it could be a movie, it could be a song, or it could be a plain text file, right? So this is what we have discussed, and we were operating on each individual element using map, flat map, or filter, or we were combining them together using aggregations such as reduce or aggregate. So this is what we have done so far. It was unstructured data because the each record was opaque to us. We needed code to process every record or convert it, right? Now, using this code, we could convert it into structured, and that's where the data frame comes into play. A data frame is an RDD. Underneath, it's an RDD where each record would be like a row in a database table. So data frame is more like a database table, which has columns and which has rows and which has column names. All right. And the good part about data frame is, although it's just a thin layer over RDD, in RDD we had no clue about the column names, and in RDD, data was not necessarily to be in every record. Data was not necessarily to be an array. It could be a large object. But in case of data frame, we have a surety that it is made up of array of values. Okay. Now the magic about a table is, the magic about a structure like data frame is that we can run very powerful logic in very simple way. For example, running a group by or running a join on two tables is very simple. But if you try to do the same thing using a code, it's little complex. Joining two data sets if where you don't have columns is very difficult with a normal programming language. That's why data frame makes a lot of sense. So the first, in solving any kind of data problem, the first objective is to convert unstructured data to some structure and then apply logic on it. You apply the logic on the data frame later on. All right. So you can apply various kinds of logic on data frame, and the general format is either the R way, R as in programming language called R, which has a structure like this, where we say, similar to SQL, we say things like where clause in this form. Okay, so the syntax of R is very similar to syntax of SQL. It just the structure is a little different. All right. So data frames again are a collection of data organized into named columns, and it's distributed. It's conceptually equivalent to a table in relational database. A data frame is in so it's conceptually equivalent of the data frame which you see in R, Pandas, or Python's NumPy and SciPy. They all have this concept of data frame. And since most of the data scientists were already very comfortable with the idea of data frame, that's why data frame has been adopted in Spark. So you can create data frame either from structured data files, as in you have already saved the structured file in certain format, or tables from Hive, external database, existing RDD. Or you can directly load JSON data, plain text file into a data frame. All right. So the data frame API is as close to the heart of Spark as RDD is. You can use this data frame API either in Scala or in R, Spark R, or in Python. So everywhere you can comfortably use the same API. All right. So data frame is not supported by Scala as such, but since Scala supports any kind of object, so Spark provides its own object, which represents a data frame. All right. Thank you, Kush, for that question. All right. So now that was the data frame. Data frame is a part of Spark SQL package of Spark, whereby the objective of Spark SQL was to be able to integrate with all kinds of data sources and be able to read and translate one form of data to another, right? So specifically for structured data processing, a package called Spark SQL was made, and data frame is one construct which was part of Spark SQL package. All right. Now let's start with it. So by default, you will get an object called Spark in the shell. But if you are submitting a program, if you are creating a program which will be submitted later, you will have to define your variable called Spark. You will have to say, well, Spark equals Spark session dot builder, and you have to import this dot builder dot app name dot config, and then you have to import Spark implicit. So if we are creating a program which we will submit using Spark submit command, then we will have to first create this object called Spark. Okay, the whole session is based around this variable called Spark. Okay, earlier this variable was called SQL context, but in Spark 2 it has been moved to Spark, plain vanilla Spark. So the entire session is around this variable called Spark. All right, so you can create this Spark variable using this syntax, as in Spark session dot builder dot application name, then set some config, then get or create. Okay, get or create is the singleton way. Singleton means there will be only one instance during the application. All right, now this variable is by default available in Spark shell. So now all of us need to get started with Spark. Okay, the way we do is we define these two variables. Okay, and also before we jump into anything, I'm going to share the slides of today. So these are the slides in the link. And before that, I've shared the command. First, we have to specify this particular config directory, and then the another config directory for the compatibility of Hadoop 1 and Hadoop 2. And then we need to execute this particular command. All right, so I'll show you this. Is the font big enough for all? Yes. Is this font okay? Or should I increase the font a bit? All right, good. All right, so let me start my shell. So first we will try with the Spark shell, then we'll try with the Spark R. Those who want to give it a try with PySpark, they are equally welcome because the syntax of almost all of the code is going to be same. Okay. It'll take a little while. So right now it's connected to the local one, not the Hadoop directly, but it can access Hadoop, by the way. Okay, so the driver is running on the local machine. And going ahead. So please notice that we are using the version called 2.0.1 because this data frame API has become stable in Spark 2. Earlier, the API was little cluttered. Now it has become very stabilized and very production ready. Okay, so we're going to use the almost the latest version, Spark 2.0.1. Good. All right. So this is our first code that we're going to do. So there is this file here at this location. I will also open that location, and here I will show you what is there in the file, and then using Scala we will read it. Similar command is also valid for Spark. We'll have to say where and then. Okay, So I'll show you what is there in that file, and then we will go ahead and try. So we are going to talk about this file, Spark, okay, slash data at the top level, and then Spark. These are the files which we are going to use today. All right, so it's very simple. You can see that it's a JSON file. Now also notice that the entire file is not a valid JSON, while each individual line is a valid JSON. Did you notice this? Each individual line is a valid JSON, and the entire file is not really a valid JSON. Okay. Now, so this is the file which we're going to deal with, although it's like tiny data, but it'll give you good enough idea. So we are saying df equals spark.read.json, and we are providing this format. Okay. In this case, it is expecting that at the top level, each line should be an object. And in JSON, when you have an object, it is surrounded by curly brackets, and it is made up of name and value. Name and value, which means that if in case you have another name value here, it's going to aggregate all of the names together and then display. Okay. Or okay, so we'll have, I'll show you. See here, there is only one column called name, while in the second one you have age and others. So it has tried to infer the names from it. Okay, let's take a look. So how does it look? So here you have age and name, right? So on top of this, we can run various kinds of commands on this data frame. We'll show you those parts. So just for time being, we'll try df.show. You can see that it has loaded the data. Looks like here it is null. Why? Because there was no age. So by default, if your JSON data is in the every line is a form of object, you can simply load it by saying spark.read.json. Okay, everybody has done it. So has everybody started the Spark shell? And then, okay. So Manjunath, you can log in, you can use these commands, okay, to start the shell, and then type these commands, this one. That's okay. That's okay. For time being, Prasant is saying getting the error looking for metadata directory. All right. Abhinav, are you able to do that? Let me take a look at your screen, Sapna and Prasant. So Prasant, could you share your screen? I'll stop sharing. And Prasant, could you share your screen? All right. So which machine are you on? Okay, you have to say where df. All right. So you have to say where. Okay, good. Good. Now say df dot show, df dot show. Ignore the warning for time being. All right. So that's just a warning. It's not an error, because you can impose a metadata on, probably you can impose a metadata on top of a data source. I think that's what it is giving the error. All right. I think the same thing Sapna is also facing. All right. So okay. So who all are able to see df dot show? Who are all are able to see this character graphics? Wonderful, wonderful. So this is the first step to deal with a JSON object. All right. Good. So the life is very simple here. You can see that we basically loaded very easily. And this is the format for Spark R. I'm going to just launch Spark R for a moment. Okay. Saptrishi, that command was supposed to be run before you started Scala. First, you export these variables, then you start Scala, and yeah, that is the order. And then on the Scala prompt, you specify, okay. So I'm going to start R as well. So this is R. Again, just like Spark Shell is a wrapper or a over, Spark Shell is nothing but Scala shell with additional variables. Similarly, PySpark is a Python shell with additional variables, additional Spark related variables. Similarly, Spark R is R R interactive shell with additional variables for Spark. Okay, here you can see, okay, so it says that it is not able to read JSON. Why? Because this is a wrong location. It should have been slash data slash Spark, because that's where we have kept all of our data. You see, the data frame comes quite natural in Spark R. So you can see, okay, I think it's show df. Yes, show df, and there is a capital capital DF. That looks little better. You see that? Now, okay. So the way I invoked Spark R is by this command. You see, using this command. If you want to try, you can try that. Okay. So in the same folder, we have installed multiple under user folder. We have multiple Spark versions, and okay. So that's it. Now, what you see here is an interesting thing. These data frames are little different from R's data frame. Who can tell me what's the biggest difference? Any guess? Yes? So I'll tell you. So this df is lazy one as compared to other variable in Scala. Lazy in the sense it would start working only when you say df.show. It won't work till the point you say df.show. Okay? All right. Similarly, unless you say so df, it's not actually a data. It's not in the memory. It's just an RDD underneath. All right. Now, let's say you want to see the schema of a particular data frame. Okay. You want to see the schema of a particular data frame. So you can simply say df print schema. All right. It shows you that just like you have a database table with all details, similarly, you can see the schema of a data frame. All right. Now let's say you want to just select the first column. Okay, then you can say this. Or let's say you want to select age. So you could say. So this is standard syntax similar to R and Python NumPy and pandas. Okay. Let's say you want to select the columns in this manner. Select first column, comma, one more value like this, and then want to display the value, meaning you want to increase the age by 1. You want to increase the age by 1. All right. Let me try. Okay. So select, I think this example is little off. All right, I think this example is for R. Okay, I'm trying, I think it's Python. Let's try. Okay, so what does it say? It says cannot resolve this output. Select, we put dollar and that will be it. Right, so you can see that this is the way you can query the data frame using Scala. All right, in the similar way we would say here, so you basically put dollar in front of the name of a column if you want to refer to the column value. Okay, so you can see that we are able to filter out data very simply by using these commands. Okay, and similarly we could also do the group by and then get the results. All right, yes, wonderful, wonderful. Any questions at this point? A question from Saptrishi. Can we select and filter together? You can chain these commands. The rule here is to basically try to chain as many of these as possible. For example, okay, so you could basically here, because everything is returning a data frame. This is returning a data frame, and on that data frame you can further chain it. For example, this followed by this. Okay, and then show. You can see that. Wonderful. All right, great, great. So these are very important operations because being a developer or data scientist, there is a very thin line. Or most of the developers, they end up being the data scientist in their career, and they will have to move from SQL to R, meaning and RDD to data frames and so on. So basically, these are very important aspect, and that's why I wanted to take separate class today. Okay, so similarly, sometimes we would like to run an SQL query on top of data frame. Now how do we do that? It's very simple. Any data frame you create, you register it as a table. Like, for example, right now, this data that we loaded from JSON into data frame, we could simply say, create or replace stamp view. So people becomes kind of an internal table here. It's not persisted, it is there. Now, all we have to do is run the queries on this temporary table. It's like a view. And then once we are here, we could say show. All right. So although it doesn't sound like a great idea, but you can see that we are interoperating between the two languages. On one hand, you have R-like syntax, whereby we are operating on a data frame. On the other hand, we have SQL. Both of them can be used simultaneously, right? Same data frame, we registered it as a table, and then on that table we said select star from people. It's the same people table which we have registered here. It's the same people table which we have registered here. Good. So whether you are good at SQL or R, you will feel at home. Okay. All right. Now there are two ways to convert RDDs to data frame. Okay, what does it mean by converting RDD to data frame? It's exercise of converting unstructured data into structured data. It's this exercise. So there are two ways. One is inferring schema through reflection, or programmatically imposing or specifying the schema, although there is a very thin line difference. But this is the standard process in any industry, that you have unstructured data and then you load it into RDDs, and then you start converting or imposing it, or you start translating these RDDs into data frames. So there are two ways to do it. One is by the way of reflection. So what does it mean by reflection? You manually create row objects. Okay, every record in RDD is like a black box, and you need to convert it into row objects. Rows are constructed by passing a list of key value pairs to the row class. Okay, and let's try to convert people.txt. This people.txt is having plain text file which is comma separated. Okay, let's take a look. You see, people.txt, it's just plain text file where the values are comma separated, and second column is integer, first column is first value looks like a string. Okay, now let's move on. So what you see here is, first we defined a class here. Okay, first we defined a class. All right, and then we put these objects in place. Okay, so let me try to show you this part and explain in parts what is going on. Okay, so here we go. All right, let's take a look. First we created sc.text file. This will be an RDD, right? Then we applied a map on this. Map means we are splitting the values based on comma. Underscore refers to the first argument of the function. This is equivalent of saying x and then saying this. Okay, and then applying translation here. We are translating the, you remember this, this was our, this will generate an array. Every record is now an array, and we are saying that attributes is an argument for this. Okay, let me uh, define it clearly. So this is a function. This is a function in which our attributes is an argument that is coming, and this is the body of the function. Okay, this is the body of the function where we are saying create a person object, and pass the zeroth value of the splitted array as a first argument, and then the first value to be converted into integer. We are trimming it, we are then converting into integer and passing it to the constructor of person. So we are constructing person objects out of it. And where did we define this class called person? By using this very what do you say, very brief syntax to create a class. Okay, we are saying case, class, person, name and age. Okay, now let's try this. All right, good. So it says that person is not found. Person is not found, and therefore let's try doing this. Good. Now we have to use these two encoders as well. Whenever we are translating or serializing a class, we generally prefer to use the encoders, although it's not being used here. All right, let me copy paste this one for everyone. Okay, so first is, all right, and second command is here. All right, now I've successfully created the df, and now I can take a look at it. Right? So I've been able to construct a very clean object, clean table out of my unstructured data by this small piece of code. Okay, this is what is referred classically as this is what is referred classically as ETL: extract, transform, and load. All right, good. Is everybody with me? All right, only 3 people are with me. Wonderful, wonderful. Great, looks like everybody's awake. And moving ahead. Now, the same table that we created here, people df, we could say that register it as a SQL. We are registering it as SQL, whatever we did in the previous exercise. And then we are saying, select the name where the age is between this and this. So we are executing a full-fledged SQL query. And also note that in this SQL query, you could join between the 2 data frames as well. Okay, if you register 2 tables, you can join the 2 tables comfortably. Okay, so now because there was a people definition already that has been overridden because we have said replace. You see that? If we say TF, or we could just show this, you can see we have been able to show that data frame. Okay, the result of an spark.sql query is again a data frame, and then you can use it again for registering another table and working back and forth between data frame and the SQL. Question from Sapna is that what did class do? Class basically created a person object. That's it. Okay, we could also use another object called row, which is implicit. Okay, that is also equivalent of doing the same thing. Okay, we basically converted the raw data into an scalar object. Wonderful question. Great. So great. So we have been able to process this kind of data. Okay, so we can take it further as well. We are trying to do encoders, as in we can translate data in other forms as well. So what we are trying to do here next is, these are just a few exercises. Here we are saying map. This is a map where teenager is an argument and we are converting it into a string. Okay, we're converting it into a string where the value becomes name colon Justin. All right, then we are defining our encoder and encoder. All right, and then we are basically using this one to override the default encoder. All right, so that's pretty much about the data frame. All right, the other way to create the object, or other way of converting this unstructured data to structured, is by specifying the schema. Let me show you. So when you cannot define the dictionary of keyword argument, as in the argument the way we did ahead of time, then we use this kind of mechanism. Okay, so here we are saying, let's take a look quickly. So we are importing the SQL types. Okay, the whatever is required. Then we are loading this text file as RDD. We are just creating a string here, and then we are splitting this schema into an array, then mapping it from this. Okay, and we are creating a structure field. All right, now we have created fields, create schema. Okay, and then we are creating the rows. That's okay, and then we are saying this. All right, let me explain what does it mean. Okay, earlier we created person object which has the column name, right, which had the column name. But here what we are doing is we are upfront creating a structure defining all the column names and then imposing it at the end. We are saying spark.create data frame, from this RDD imposing this schema. Just that this RDD should be containing the row objects. All right, that's all. That's all is the way to create and specify schema. Now you can process this and take it further. All right, so whatever way is comfortable for you, I mean, personally I prefer the way of creating an object class like person, the way we created and then we defined it. Otherwise you can choose the second method as well. Okay, now Spark can load data from all kinds of data sources. Okay, like for example, if you want to read data from, okay, from a parakeet file. Parakeet is a new format. It's a columnar format. The way HBase was creating its own format while saving data, in the same way, Spark saves data into this parakeet format. And this parakeet format is columnar and is very well tuned for the large objects. So the syntax is very simple. Syntax is Spark read dot load this. By default, if you don't provide any format, Spark tries to load it as parakeet file. Try to think that it's a parakeet file, and then then once the data frame is ready, you can do whatever you want. Similarly, while you save this, it's going to save it again as a parakeet if you don't specify a format. Okay, sometimes you may want to specify a format such as JSON. You could say spark.read.format JSON, or you could simply say spark.read.json and then the whole file name. Okay, so these are the two ways of doing it, the way we did earlier and this way. Okay, so we are saying df.select, we are picking up these two columns and that's it. Okay, this we have already done once. And then the interesting part here we are trying to show you is you can save a data frame loaded as JSON into some other format. Okay, and then, all right, and then it is saved. All right. Question from Sheikh is that how does the parakeet file looks like? It's a binary format. I'll show you. Let's take a look at parakeet file. All right. This is users.parakeet. Okay. It's not able to read it. And if you want to enforce it, you can go to the console and say Hadoop fs minus cat data spark users dot parakeet. It's parakeet. I think that's the way it's pronounced. How is it pronounced? I think it's parakeet. All right. So you can see, Sheikh, the format, right? It's more or less binary followed by the schema in the form of JSON. Make sense? You all can take a look. Wonderful. Moving ahead. Now, so sometimes you may want to directly query a parakeet file or say JSON file from the database, from the query. Let's say you want to read this file, whatever I have shown you just now, without having to deal with data frames. So you can simply say select star from the format colon the backquotes. Note the backquotes. Okay, backquotes are the ones which are just next to your escape key on the keyboard above the tab, and backquote close, and that's it. Okay, so this way you can load most of the data easily. Right. Now you can see SQL df.show. So parakeet file you can load in a very simple way, as well as you can load JSON in the same way. You can say JSON here, and then you can load this. Okay, you could specify the absolute or relative path from your HDFS. This file is located in my home directory in HDFS. Let me show you that part. So this file means it is in my home directory. Okay, let me experiment a bit. Okay, anybody wants to just take a look, although it won't run for you because you don't have this file in your home folder. Okay, so if I say users and say /data /spark, and if you do this, will it work? Let me take a look. Yes, it did work, just that it loaded this way. Good. And you can see that in a data frame, each column itself could be a complex object, such as an array. All right. And let's say if we are trying to say load JSON, will it work? If I say people.json and I specify the format as well, will it work? Let me try. Okay, it looks like it did work. Yes, it did work. All right. So I'm going to just copy paste it for you. All right. And where is my good? So yes, I'm going to put this instead of the other command because this is more practical. And I'm also going to save this particular one. Great. Any questions at this point? All right. Now, you'll be surprised to know that it's very, very simple to interact with Hive from within Spark. Okay, so from the shell itself or from your program, you can talk to Hive. Just that you have to, by default, Spark comes with a Hive support. And also you have to copy hive site.xml into the Spark conf folder if you are installing. We have already done it for you, so it should work out of the box. All right. And sometimes if you want to provide some of the extra jars, you will have to provide by the way of -jars command in the Spark. Okay. All right. So Hive tables are very, very straightforward and simple. You remember our employees table that we created in Hive? Okay, I'm going to just take a look at it quickly. So here is our data browser, query, and Hive, right? And we created a table called employees there. So by default, it talks to the employees table, but you can always change the database. So let's say we have employees table here, and in the default database, there is this nice table which we created, employee. Okay, so if we say what is there in the table, okay, sample, oh, it's empty, almost empty. All right, then employee, select star from employees. Okay, so when I say select star from employees from default database, it's not giving any results. And what about SG? Let me just try a little more. Okay, so this is empty. That's not right. It's all null. Employee 2016. Does anybody have some data which I can show? Employee 22. Or is there something wrong with it? A question from, okay, there's no question actually. I thought, okay. We have, can I just pick some table? Employees. I think employees has something in this. No. Yes, let's take a look at U underscore data. Is there something wrong with it? There's something wrong with. Hmm? Okay, never mind. So let's try querying it. I think it does work from here, although it's not working from its own place. So it's pretty simple. All you have to do is you can actually import directly here the SQL one, so that you do not have to type the whole command, and then you can simply say SQL like this. So let me take a look at it. What does it say? The input path does not exist. Looks like this particular folder has been deleted. Okay. Does this folder exist? Okay, so let me take a look if that Hive folder location exists. Yes, it does. And let me try to see if, okay, sg.db. All right. So here we have quite a few tables. All right. We just need to find out. Okay. Can I try some other? Let me try some other, saying sg.u underscore data and df.show. Looks like some of the data has been deleted. Never mind. I think somebody has done some mischief. And hmm? Right, right. Never mind. So it does work fine. It's just that at this moment there seems to be something wrong with the folder. All right. Okay. So let me take a look at. Right. So yeah, this one is looking fine. Okay. So where df this is looking fine. All right. So you are able to kind of load this, and we could register this. Register this as a SQL one, and then you could basically query this data and do all kinds of magic. Okay. So that's about the talking to. So any command like load, create table, drop table, anything can work from here. All right. And therefore it's quite simple to use this as compared to others. All right. Now, sometimes you may want to talk to the JDBC. All right. So you may want to talk to JDBC. It's very simple. If you want to do it now with me, you can do it. So all you have to do is first copy this particular connector to your local folder, and then run the Spark shell. This command is copying this particular file from Hadoop HDFS to your local folder, and then and then we are going to use this particular driver. This is MySQL driver, and then we're going to use this on the command line to launch. Okay, in case you have written a program which needs to be submitted instead of interactively working with it, you might have to you might have to in case you have you're working on a program which need to be submitted using Spark Submit, then you will have to mention this in Spark Submit dash jars, this particular driver. Okay, so now you can see that we have started the Spark shell with these two arguments, driver class path and the jars. Okay, and then we're going to use this command to talk to SQL. Okay, MySQL actually. You remember where was our MySQL command? You could go to CloudX Lab and go to MyLab, and that's it. Okay, so basically you can find out these details. And here what we are trying to do is we are saying use this particular database URL. We are going to use ScoopX, and then we are going to load this. Okay, let's try. All right. This is the same table that we used in our Scoop. Okay. So right now it's trying to talk to JDBC, the MySQL, and here is the data. You remember this table when we imported using Scoop? The widgets table? All right. So we were able to successfully load the data. Just give me 5 more minutes and we will be done. Okay, so we were able to read data from the HDFS and as well as from MySQL, from Hive, and also we were able to read data from JSON, Parakeet, and plain text file, and we can also load in the similar way the XML kind of data. All right, or if there is no formatter available, you can code your own using Scala, and that's it. Or in case you don't want to code and you know that something is already developed by somebody in Java, you can use the same classes in your Scala program. Okay, and if nothing works and you know that it is working fine in Python, then you can load the data in Python, save it as parakeet, and then load here, save it as parakeet in the disk, and then load it here using parakeet format. So basically you have many more options of interoperating with Spark. Okay. All right, so it also provides something called Beeline, which basically lets you connect directly to Hive. And all right, now a brief about what is Spark R. Spark R is basically just like Python, which is basically a Python shell with extra object from Spark. Similarly, Spark R with extra objects. Also, Spark R provides the machine learning libraries provided by Spark into the R kind of format. Okay, we will talk about it again. So Spark R data frame is a distributed collection, just like our usual one. It can be constructed from all kinds of sources. Okay, because R works on data frames. All right, then the way you launch Spark R is this way. We have already launched it, and here is an example of using R. We have created a data frame, and here we are saying create data frame from Spark with this data set. This data set comes with R by default as an example. It's basically the volcanic eruptions data, which shows that how many have happened and how many are waiting. So basically this data, or you can similarly read the JSON data, from R, and that's pretty much similar to what we have done so far, right? It's very much the way we earlier did was we said spark.r dot JSON. Here we are saying read.df and then Spark and then providing the JSON. Okay, just the difference in the order of things. And we can basically dissect the data, select columns, and all right, do the operations on that data. Okay, so you can do the aggregation, grouping, and then grouping and aggregation combined together. You can operate on columns like filters, and here again the entire example in a single shot. And sometimes from within Spark R you may want to use SQL. That's also very much possible by just saying SQL Spark and then executing this command. Just that you have to register a temporary table. So the language has changed, but the philosophy is similar. Okay, whether you use data frame or SQL, it doesn't matter. It's just the language R, it is R, and the other one was the Scala. And similarly, Python. In all these three, you can either operate on SQL or operate on the data frame. All right, so that's pretty much about the Spark SQL, Spark R, and data frames. Do you have any questions for me? Okay, so this slide has been made available in the yesterday's session itself, and we're going to yeah, we're going to upload the video as well. I will create one more or two more sessions in the course, and these videos and slides will be available there. Okay, all right, great. Thank you all. Thank you for joining the extra session, and I'm sure you would like these two sessions. All right, I look forward to see you tomorrow again at the same time. Bye bye. Have a good day. Please make sure to execute the same thing by yourself. All right. Thank you, everyone. Thank you, Abhinav. Thank you, Anup. Thank you, Jen. Thank you, Karthik. Thank you, Manjunath. Thank you, Nada, Nitin, Omkar, Prashant, Ramana, Sapna, Saptrishi, Sheikh, Stephanie, Sundar, Tad, Thomas. I think Thomas had to leave earlier. Okay. Bye bye. Have a great day ahead. I look forward to see you all tomorrow.